Good day, everyone. Today, I will be discussing the screw pump. What is its function? What is its working principle? What are its parts? And the other important details. So, to start with, where does the screw pump originated? In irrigation pump in Egypt 1950s, the screw pump is the oldest positive displacement pump. The first record of a water screw or a screw pump dates back to ancient Egypt before the 3rd century BC. The Egyptian screw, used to lift a water from a Nile, was composed of tube wound round a cylinder. As the entire unit rotates, water is lifted within the spiral tube to the higher elevation. So, in 1950s at Egypt, screw pump or a water screw was used as the irrigation pump, so the ancient construction is still used as many low-tech applications such as irrigation system and in agricultural machinery. So what is screw pump? Screw pump is a pump in which the working pressure is created by means of screw-shaped impellers in the vertical water column. A screw pump is a type of rotary pump which is equipped with screws and meshed together and rotate within a cylindrical cavity or a liner. So this is the one of the example of the screw pump. As you can see in the picture, it is a screw type form of a pump. Now, what is its function? It makes the fluid enters from the suction side of the pump and moves linearly along with these intermeshing screws in the discharge side of the pump. So screw pump makes the fluid transfer from suction line to the discharge line. One of the questions of the same people ask, is the screw pump dry running? So yes, the screw pump can operate even if there is no water. So this is the parts of a screw pump. So what are the parts and its function of the screw pump? So number one, the driver screw. This is where you locate the driver screw here. This is the driver screw at the screw pump. The driver screw helps pump the fluid at a constant volumetric flow at any point of rotation. So number two, suction and discharge port. This is the suction port and this is the discharge port. The suctions and discharge port holds enough amount of fluid when pumps finally stop. So this suction port is when the water is entered this, and when the propeller is acting like entering the water and holds when the engine is stopped. So number three, the drive-in screw. This is the drive-in screw. Drive-in screw is made of the same material of the driver screw. They are the same. Number four is the timing gear. This is the this is where the timing gear located at the in between of the rotating seal and the stationary seal. The timing gear is a part of screw pump that ensures the opening and the closing of the driver and driven. So number four, Rotary and stationary pump. This is the rotary and the stationary seal. Rotary and stationary seal are fitted with a pair seal. This will keep the bearings and the timing gears separate on the side of the pump. Um, this is where you located the rotary and the stationary seal. So number 6 is the driving shaft. This is the driving shaft. Yeah, this driving shaft is the part of the pump that connects the pump to its driving motor. This is where you located. This is located here, the shaft, the driving shaft. Number 7 is the bearing. Bearing is here. Here. Bearing is a type of rolling element. Its purpose is to reduce the rotational function, friction, and support the radial and axial loads. So the last, relief valve and the recirculation line. This is the relief valve and this is the recirculation line. So the main purpose of the relief and the relief valve and recirculation line is to prevent the pump from overheating. So this 8 is the most important part of the screw pump. The spring is when the shaft is rotating, they will like acting on same same distance, and the o-ring is when you is the seal of the o-ring is located here. O-ring can act is acting like a seal of the rotation seal and the stationary seal to prevent leak. So what is its working principle? A screw pump generates pressure by adding axial acceleration to the fluid medium within its fine clearance area. Unlike gear pumps, with one gear driving the other, these have three positive effects on a pump performance. The first is the low output fluctuation, second is increased efficiency, and third is the increased bearing life. Due to its tendency to generate high vacuum pressure, it does not require priming and thus self-primed. This pump came with a rotational speed of 800 to 2600 rpm range in general. So the pump or the screw pump, its constant speed is its constant rotational speed is 800 to 2600 rpm. That's the constant speed of the pump or its working principle. So where should we use screw pump? Screw pump. While a screw pump can be used with almost any fluid medium. So meaning screw pump is almost used by the fluid or the restocking the water into reservoir. There are situations when it is more advantageous to use over others. A screw pump is the best suited for application where we require non-pulsating constant output, have medium with trapped air or gas, working with high viscous fluid, and have low NPHs with the ability to withstand dry run for a short time interval. So this slide is the presentation for a screw pump and its uses and its principles. So
The Alfa Laval twin-screw pump designed for process flexibility to handle both product transfer and cleaning in place, with the ability to move seamlessly between the two. Consisting of multiple model sizes with various screw pitch options to cover a wide performance envelope, allowing for multiple applications. Superior suction performance provides for installation flexibility and increased product recovery, making it ideal for emptying both portable containers like IBCs or totes, as well as static suction vessels. An excellent MPSH characteristic minimizes the risk of cavitation. The Alfa Laval twin-screw pump ensures smooth and gentle operation and can handle multiple process media of varying viscosities. Its superior solids handling capability also reduces the risk of product damage, thereby improving the product quality. A low pulsation characteristic reduces the potential for product damage, whilst minimizing noise and vibration, extending component life and pump reliability. In addition to process media, the Alfa Laval twin-screw pump can also handle CIP duty by simply increasing pump operation speed. This simplifies piping and control complexity, reducing associated costs whilst minimizing potential contamination points. The Alfa Laval twin-screw pump is also able to transfer liquids that contain a high percentage content of entrained air or gas. The optimized design, carrying approvals including EHEDG, 3A and FDA, reduces contamination risks and CIP cycle times, cutting cleaning and waste management costs. A uniquely designed cartridge seal, fully surrounded by high-velocity CIP media, ensures effective cleaning. Profiled elastomers in the pump ensure faster, easier cleaning, thereby eliminating any risk of cross-contamination. The Alfa Laval twin-screw pump is both practical and hygienic. Designed for quick and easy maintenance, changing the shaft seals with the pump in position is simple, maximizing process uptime and minimizing total cost of ownership. Incorporating the unique Alfa Laval twin-screw cartridge seal, a truly front-loading seal, easily accessed by removing the retention screws and simply pulling out of the seal housing. There are three options for the Alfa Laval twin-screw cartridge seal: single, single flush, and double. Each has a range of seal faces and elastomers to meet various application needs. Retrofitting from a single to single flush or double seal is easy. Should the pump application change, the user can simply change sealing solution, providing full process flexibility. Seal replacement is simply pushed in, without the need for manual setting, using either a new cartridge or a previously used seal, refurbished utilizing a seal service kit. Optimized screw design with 3-pitch variants provides the user with process flexibility to appropriately select according to flow, pressure, and solids handling requirements. The Alfa Laval twin-screw pump is designed with easy screw timing in mind. This can be done in position without the need to drain the gearbox oil or removal of coupling and motor. Timing gears are easily accessed via removal of the gearbox top cover. Screw timing is achieved via a simplified procedure through easy adjustment of the timing gears, whilst measuring clearance between the screws. A rigid and robust all-stainless steel gearbox prolongs component lifetime and reliability, increases process uptime, and reduces maintenance cost. The timing gear is located between bearings to optimize the bearing span. This balances loading on the shaft assembly, reducing vibration and noise, further extending component lifetime. The design of the oil chamber enhances the lubrication of the bearings and gears. This reduces the gearbox running temperature, increasing workplace safety, bearing life, and pump reliability. Designed and precision engineered by Alfa Laval using decades of proven technology. Hygienic, flexible, easy to service, and reliable. The Alfa Laval twin-screw pump joins a broad hygienic pump portfolio, including centrifugal, self-priming, rotary lobe, and circumferential piston technologies. This comprehensive pump portfolio lets you optimize your process by choosing the best pump to meet your process and application needs. Complete just became more complete. Backed by the global coverage with local presence, offering sales and service support, Alfa Laval pumps are tailored to meet local specifications for many applications. The Alfa Laval twin screw pump, delicately robust.
So that's all. That video contains the uses of a screw pump and its principle. So as you can see, when the driving shaft start to operate, the water enters to the pump, and of course they have to go in the discharge pump, so it will come up with the so it will go to the reservoir. Then as you can see, the in the video there are many types of the pump. So thank you, and that's all. God bless.